All right. So yeah, we only have, geometric power series. We're going to get through this today. And then we'll have section 9.7, which is error approximation. And then we'll have some practice AP questions. So today, new material. Wednesday and I think Thursday, the next section of notes will be splitting that into two pieces. We're going to go all through this today, 9.9, the section here we'll get through all today. And then again, Wednesday, Thursday will be two sections or two parts of the same section. And then Friday will be practice AP. So really, we're done learning new material after Thursday. So, unless you never learned it in the first place, in which case some of the stuff will be new to you. But anyway. All right. So, which is going to happen, right? Because again, we don't have as much of a command of some of the topics as maybe we would like to or need to, kind of thing. So, or we forgot some things, so that happens. Okay. Anyway, so consider the series, the sum from n equals 0 to infinity of x to the n. We know that this sum can be written as, well, right? So we start with n equals 0, so it'd be x to the 0, which is 1, right? Plus then x to the 1, plus then x to the 2, plus x to the 3, plus all the way up x to the n there, right? Okay. This expression closely resembles the sum of a geometric series with a, or I should really call that a sub 1 being what? What's a sub 1 here? 1, right? 1. And what is r, the common ratio, or the thing that we're multiplying by repeatedly every time? X over 1, or I'm just going to say x just in this case. But yep, x over 1 is not wrong either. Okay. Therefore, right, the sum of this series would be, well, remember here, right, that for a geometric series, we know we more typically see it written like this, right? A times r to the n, right, equals, and then a over 1 minus r. Right, that's the typical sum right there. So for this particular geometric series that we've got right here, where we just have x to the n, how would the sum be represented here? So what's our first term there is 1, so it's going to be 1 over 1 minus what? X, right? X, exactly right. Okay. Keep in mind, also, using what we know about like power series and Taylor series and all that stuff here, we have a center, right? What's the center here for this particular problem? What's the center? It's 0. It is 0. Yeah, it's 0. Okay, this is centered at 0. Yeah, c equals 0. Because, of course, if we were centered at another number, we would see something like x minus, c, right? X minus some c there for our center. Okay? So we can now express functions that look like the sum of a geometric sequence as a geometric power series. Okay? Right? So we've kind of dealt with, if you remember, there were like 4 power series that you're responsible for, recognize the format. We've talked, about sine and cosine and e to the x quite a bit. But we haven't done a whole lot with geometric series. And here we are now going to be doing that. Okay, so we're taking those series, or the sums, functions in the form 1 over 1 minus x, or a over 1 minus x, and rewriting them as power series. Okay, so here for a more generic situation, right, scenario where we have a times x minus c to the n, so it's centered now at c. Okay, c doesn't have to be 0, so we could center it elsewhere. What would this look like, right? Well, we just, again, expand it out here. So I'm going to use a sub 0 as my first term here just because, it's n equal to 0 is where we're starting there, but it's still the first term, okay? And it'll be x minus c to the 0, so it's just going to be 1. But the next term will be a sub 1, x minus c to the 1, plus a sub 2, x minus c to the 2, plus 1. You get the idea here, right? Okay. Plus dot, 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 equals... And so again, using what we know about geometric power series, what goes in the numerator? A sub 0 in this case for our very first term. Yep. And then in the denominator, it'll be 1 minus what? what are we repeatedly multiplying by every time? X minus c. Yeah, so 1 minus the quantity x minus c. Okay, 1 minus the quantity x minus c. Okay, and so that's our form that we're going to kind of look for, right? We have this series that's then represented by this function right here. Okay? So let's take a look here at example 1. Write the following expressions as a geometric power series. And then write the first 4 terms. So here we're given functions, right? And we want to rewrite them as a power series. So we want to make sure we kind of match the form that we need here. Okay, so let's take a look just at this very first example. Okay, so this is in the form of a geometric series, right? We have a number divided by 1 minus something, and so we're going to just pull out the important information here. All right, for a geometric series, we need to know what our first term is. So what is our first term going to be here, according to the formula, or the format there? It's 12, right? It's right up there. It's 12, okay? So we can say like A equals 12 there, okay? And then what's our common ratio according to this form here? 1/4, right? We're trying 1 minus r, so our r there is 1/4. Okay, and so then we can just write our series here. The sum from 0 to infinity, 12 times 1/4, or 1/4 to the n. Way back, last unit, right, we saw a series like these maybe, and we were asked to, find their sum. And now we're kind of working backwards, right? Given what the sum is, use that to then now find the series. Okay, and of course they asked us to find the first few terms here, so that's pretty easy. Again, imagine just plugging the 0 in. 1/4 of the 0 is 1, so we start with 12, and we're just going to repeatedly multiply by 1/4. So 3, 3/4, 3/16, so on and so forth there. Okay. Okay. Now, we look at letter B, all right, and we see slightly different formatting. Now we have an x thrown in there, and it's x plus 2, okay, but again, it matches this form. Okay, we can say it's going to be geometric because we can see that form there. We have the a over 1 minus r kind of formatting there. Okay, you can kind of see it. Okay, and again, don't forget, it's important to have it to be a over 1 minus r. Now, all these problems here have 1, 1, and a 1 there on the letter C as well. Okay, so they all have 1 in their denominators, so that's good to know. But we need to match that format, but this one does. Okay, so according to this one, right, what is a? What does a correspond to here in our function? It's 3. Yeah. Okay, so 3 times. And then what is our r? X plus 2. X plus 2, and that'll be then to the n, because we're going to repeat and multiply that right, by the common ratio. So that x plus 2 then indicates what kind of characteristic? The x plus 2 part indicates we are what? Centered, right, at not 0, but negative 2. Exactly right, Sarah. Yeah, we're centered at negative 2. Okay, so I'm just going to note that here. Because remember, again, the formatting is x minus c. So if we have plus 2, that means minus a negative 2, which is really then just negative 2 there. Okay, the formatting should be x minus c. So we need to rewrite that, or imagine that rewritten. And then, of course, we can write out the first 4 terms there. So it'll be 3 plus 3 times x plus 2 plus 3 times x plus 2 to the 2 plus 3 times x plus 2 to the 3 plus ... You get the idea. Okay, 4 terms there. Okay, so nothing too crazy, right? Just have to pull the pertinent information out there. All right, so let's scoot over here and take a look at letter C. So is this going to be, well, so let me step back one here maybe. So this is geometric, right? It's geometric. We're told in the directions it's going to be geometric there, so it's kind of hinted at it, right? What would our a be in this case? 5x squared, okay. What is our r going to be? So yeah, negative x, right? Negative x. You might see that, I got you. You might see that 1 plus x there, right? And think, oh, it's just going to be, it's just going to be this, right? We could just say, sum from n equals 0 to infinity of, 5x squared times x to the n. But the issue is, right, that's not quite the right format to just pull that r out and say, oh, r is x here, right? Because it needs to be 1 minus r, okay? So these are not equal to each other. Instead, right, we want to take that 5x squared over 1 plus x. And again, I know this is very elementary. You guys may be able to see it, but I'm going to rewrite it here in the appropriate format, right, just to really emphasize that we want to match the formatting of a geometric series. Okay, you want to match that formatting. So I'm going to take the time and rewrite it here, just because, again, it's notes, so it's helpful to see. And now that we see, the appropriate formatting, a over 1 minus r, now we can rewrite it correctly. And say it is 5x squared, but it's times negative x to the n, like that. Okay, and so that's the series, and of course we'll write out the first few terms there. So that's going to be equal to 5x squared minus 5x to the third plus 5x to the fourth minus 5x to the fifth plus dot dot dot. You get the idea. Okay. Questions on any of that? So far, so good. Okay. So, and that's basically what we're going to be doing here, is just trying to rewrite things to make sure that they match that appropriate format. Okay. So that's our goal there. Example 2, find a power series for f of x equals 4 over x plus 5 centered at the following values. So both centered at 0, and then later we're going to do centered at 3 as well. Okay. Then find the interval of convergence for each power series. All right. So let's see here. So I'll give you guys like maybe a minute here. Go ahead, you guys give this one a try. Letter A is centered about 0, c equals 0 there. So see if you can figure out how to manipulate this to make it match our form of a over 1 minus r, okay, which is then we know equal to the sum from 0 to infinity of a times r to the n. Okay. So go ahead, just try and come up with that power series there with what you see. Okay, you may need to manipulate things a little bit, but I'll give you at least like a 30 seconds to think about it, if nothing else. Okay. Rather than me just tell you the answer. Okay. Give me a few more seconds here. A little bit longer. 30 more seconds. All right. So that 4 over x plus 5, right, not quite in the formatting that we're looking for. First of all, the denominator has no subtraction, right? We need to have something minus something, right? But specifically, we need a 1 minus something in the denominator, all right? So, and normally it's, it can be 1 minus and then our x term kind of thing. So what we're going to do here is take that function f of x, all right? Again, our goal is to have some a over 1 minus something with x here, like this. Okay, we know it's going to be just x, by the way. We know it's going to be minus just x because we're centered at 0, right? And so we're going to have just minus x by itself because we're centered at 0 there. So we want to rewrite it so it's just minus x, okay? Really. Well, so we take that, 4 over x plus 5, and the numbers are kind of out of order there. We're going to make it 4 over 5 plus x, which, again, forgive me for, that's such a basic step there. But it's going to be helpful because, again, we want the number first, then minus x. Okay, let's first of all take care of the fact that this 5 should really be a what number? It should be what? 1. We need it to be 1. So we're going to divide, okay, we're going to divide through by 5, okay? We're going to, or multiply the top and bottom by 1/5 if you want to think about it, right? So we'll do like 1/5 on the top times 1/5 on the bottom to make it, we're really multiplying by 1, and so that creates 4/5 over 1 plus 1/5 x, like that. Or x over 5 if you like. Okay. So we now have a 1. What do we still need though to make it to make it match our form for the geometric series? We need to be negative, right? We need 1 minus. So what's that? Well, I mean, we're just going to make it 1 minus then negative x over 5 kind of thing. So yeah, we're gonna rewrite it. Yep. So we need 1 minus, and so we'll make it then 4/5 over. I mean, I know you can. I mean, are you trying to say, Landry, you can just read it and just you can just pull it out, right? So I understand, but again, I just want to go through the process of making sure that we're, if you just want to do it mentally on your own, that's fine. But for the notes purposes, I want to make sure that we're, more specific than we maybe ordinarily would have to be. Okay, and so there's our final formatting right there, okay? We are in the right format. We've got, our a over 1 minus and then stuff with x there, okay? So this is the setup to be a geometric power series centered at c equals 0. If we wanted to be centered elsewhere, we would have additional work to still do, kind of thing. But we're just centered at 0, so we're good to go.
Like the next one.
Like the next one, foreshadowing. Okay, so let's now put this in the power series format. So why don't you guys, again, I'll give you if you didn't do that yet, so go ahead, take 10, 20 seconds there. Now that we have it in the right format, go ahead and write that now as a series, right? Put it in the summation notation. So, f of x equals the sum from 0 to infinity of blank. Okay, so go ahead and take 10 or 20 seconds to do that here. Time's up. All right, Mike says time's up. Yes?
Why can't we do what we did for example B on why can't we just take why can't we just split it up into 1 plus x plus 4 and then just make it in
1 plus x plus 4. Okay, I'm sorry. I'm
because x plus 5 is 1 plus x plus 4, so then you're getting the 1 plus would be minus negative, and then you do that.
I see. So you wanted to make. Actually, I'm not sure I follow.
Okay, so
You go to example B.
Letter B. Mm-hmm. Oh, on the previous one, right here.
He's saying, why can't you just make it 1 plus the x, whatever, x minus 5,
Mm-hmm.
and then swap it to 1 minus?
So I see what you're saying there. Because if we do that, right, then we're no longer centered at 0. Right? This one right here, because it's x plus 2, is centered at negative 2. This one would not be centered at 0 if you have that add subtract kind of deal. Right, whatever you added, yeah. Right, yep, and that's the trouble. We want to just have an x divided by something is okay, right? It's still centered at 0, though. We don't have x plus or minus anything, though, because if we want to center it at 0. But we'll see that for letter B. We're going to do something like that, though, for letter B, Sean. So you're on the right track for letter B, at least there. So So anyway, there is our geometric series written out. All right, it might be helpful. Also, I'm just going to write this out because, it might be helpful to see that this negative x over 5, right, you can really say that's 4/5. I'm going to pull a negative 1 to the n out, and then negative x over 5 to the positive n. So we see it is alternating there, right? Okay, but just to kind of show that it's helpful to see that you can do that, right? I just want to make sure you see that. I wouldn't say it's necessary for this problem, but it's helpful to see that. So I just wanted to throw that in there. Okay, but we're not quite done, right? So we've got the power series. There's our answer for the first part, right? But then we also want to show that the interval of convergence. We want to show the interval of convergence as well. Okay, so remember to do interval of convergence. Way back when we first started talking about this, there were two tests we could use for interval convergence, right? With a typical one that we've been using up to this point was the ratio test. Okay, but we also have the geometric series test too.
So which one are we going to use first?
Geometric series. Okay, because of course we're talking about a geometric series, right? So, what are the rules for geometric series test, right? We know it converges if what is true? The common ratio, the absolute value of the common ratio, yep. Less than 1, right? Less than 1, strictly less than 1. We know the geometric series diverges if the common ratio is what? Greater than or equal to 1. So, at this, with this scenario for the geometric series test, okay, are there going to be any values that are inconclusive? No, this is unlike the ratio test. This is unlike the ratio test, right? The ratio test, if you get exactly 1, right, that means inconclusive, right? Inconclusive. That's why when we do the ratio test, we have to check our endpoints, because those endpoints are like at the 1 kind of thing, or at that, the end. We have to check those endpoints. Here, at the endpoints will always diverge. Okay, so no need to test endpoints.
Oh, no way.
Yeah, you get to miss that part. So it's nice, very convenient when you have that geometric series. You don't have to test the endpoints. Okay, they just always diverge. So then all we have to do now is take our r, and what is the r in this problem? It's the x over 5. We're just going to make it x over 5. You can make it negative x over 5 or positive x over 5 because it's in the absolute value there, right? So if you want to make it negative x over 5, that's cool. Less than 1 like that, okay? And then we rewrite it as an inequality, negative 1 less than negative x over 5 less than 1. Okay, and then what do we do? Oops, wait, I took absolute value there, so let me leave it positive. My bad, sorry. But anyway, what do we do now at this point to finish solving our inequality? Multiply by 5, right? So it's negative 5 less than x less than 5. Okay, and so there's our interval of convergence.
How did it just become a positive x over 5?
Oh, because, well, I mean, because it's in the absolute value there.
Okay.
Yeah, I mean, it turns out it won't really matter, but it's okay. We'll do the absolute value there. In this case, it wouldn't matter. But okay, what is the center of our interval of convergence here? 0, right? And again, we saw that earlier with the calculation, right? We want it to be centered at 0, right? That's like our stipulation there. And then what is the radius of convergence? 5, right? It's the distance from the center, 0, to then the edge, 5 in either direction there, from 0 to 5, 0 to negative 5. All right, questions on any of that? So I think the most challenge here you're going to find, or I think we're going to come across, is just being able to take what we're given and rewrite it into the appropriate form. Okay, that's going to be the trickiest piece, I think. So for example here, now we're going to change up where our center is. So keeping the function, changing our center. Excuse me. Okay, so our first term, the formatting here then we're looking for is not a over 1 minus x. We want a over 1 minus, since we're centered at 3, x minus 3. Okay, that's the formatting we're shooting for now. because we're centered at 3, so you have to imagine we're going to do what is essentially a horizontal shift, right? Don't we know how to do horizontal shifts? You know, in this case, since we want to go to from a center of 0 to a center of 3, we're going to shift this right 3. How do you shift something right 3? You manipulate just the x there, and you subtract 3, right? X minus 3 ends up with a shift to the right 3. So we're just going to shift everything right 3. Okay, we're going to shift everything to the right 3. Okay, but that's going to then adjust our interval convergence and stuff too as a result. So anyway, let's go about this then. So now we're going to take our function, and it's a little bit trickier to manipulate, right? We'll start with that 4 over x plus 5. And again, I'll rewrite it so that it's now 4 over 5 plus x, right? So we have the number first and then the x. All right. And then what I'm going to do at this point is manipulate things so that we get that x minus 3. Okay, so we get x minus 3 here. Okay. So in order to get an x minus 3, well, I'm just going to put it in. 4 over 5 plus x minus 3. But of course, if I introduce a minus 3, I would also have to introduce to balance it out. Plus 3, right? So we'll just put a plus 3 there in the denominator as well. Okay, I want this x minus 3 to kind of be grouped together. So I'll have 4 over plus, x minus 3 there. But then what's going to be in front here? An 8, right? Because the 8, the 5 and 3 make the 8. Okay. So there's that. Okay. And so of course we don't want an 8 in front though. What do we want? What number do we want that to be? 1, right? So we'll just divide or multiply by 1/8 or divide through by 8, whatever you want to say there, kind of thing. Okay. So divide by 8 or multiply by 1/8 there, whatever you want to say. Multiply the top and bottom by 1/8, divide the top and bottom by 8, same thing, right? And we end up then with 1/2 over 1 plus the quantity x minus 3 over 8. Okay, and we have one more little thing we need to manipulate, right? We don't want 1 plus x minus 3 over 8. We want what? 1 minus. And so we'll then just rewrite that 1/2 over 1. And then we'll just make this a minus, and then I'm going to make it x minus 3 over negative 8, like that. Okay? You can decide where you want to take the negative. You can take the negative into the numerator and make it negative x plus 3 if you want to, right? So maybe some of you saw this and like, oh, let's make it minus negative x plus 3 over positive 8. That's one way to do it. Or you can take the negative into the denominator and make it just x minus 3 over negative 8. That's okay too. Either way, kind of thing there. You have options. Okay. So then our excuse me, our series there, it's in the right format. So now we can say the sum from 0 to infinity. Our a, our first term, is going to be 1/2. And then our r is what here? X minus 3 over the negative 8, exactly right. Or the negative x plus 3 over positive 8, if you like. Again, however you wrote that. Okay. So there's our power series. And then why don't you all go ahead and do the interval of convergence, right? So go ahead and do the interval of convergence. So we'll take that r and go ahead, find the interval of convergence there. Seems weird.
Oh, no, I need to make that positive 8 because it's.
True. You can make it -8. You can keep -8, but when you multiply both sides by -8, then inequality signs flip. Remember when you multiply an inequality by a negative number?
I feel like it's just easier to look at the absolute value of that too.
Okay, well that's fine, but
Look at it. That's his jet. Is this useful for something other than one, right?
okay. So you should have gone from -5 to 11. Okay. Our new center is 3. That's good, right? And again, how can you figure out what that center is? Well, remember you just add them up, right? -5 plus 11, that is 6, and then divide by 2, right? Anytime you want to find a midpoint between two numbers, add them up, divide by 2, right? It's like the average, right? That's what you're doing. So we do have the center of 3, which is good, and then our radius in this case turns out to be 8, right? Okay. That's how the cookie crumbles, that's right. Okay, so we see we have the right center, though. It's a center of 3. Okay. Any questions on any of this? Yes, Kara.
Were you able to get rid of like the negative 8 on the bottom, but that's still x minus 3?
How are you able to get rid of the? Oh, I see what you're saying, and then but still make it x minus 3, right? So here's the thing. I see what you're saying there. Let me think.
Just like it has to divide it straight up.
So the negative. I see what you're saying there. I mean, we could do so. A way to kind of like maybe avoid having to worry about this is we could say that this is, the sum from n equals 0. We can make it and I see what you're saying though. So why don't we make the x minus 3 positive there? Because I think we can't. I think it has to do with the fact that this is division of a negative as opposed to like subtracting 3, right? So like we can imagine, like you could imagine taking this -1/8, we can like factor that out, and we can make it, the quantity x minus 3, and then pull the -1/8 out, make it positive 1/8 because we pull it outside the absolute value there. But the x minus 3 itself, you can't break that up like individually from the absolute value, I guess, or something. I don't know. I'm not sure I can come up with a good explanation of why we can't make the x minus 3.
I just like made them maybe like positive.
Okay.
I got like a weird answer.
I was gonna say, so if you make them, well, let's just see that here. Yeah, and then you end up with the exact, in this case, the exact opposite of, yeah. So it should be, yeah, the exact opposite there. So let me think here. I think I know where I made an error here. I think I made an error in my yes. I think I know what I did here. So it's actually an error in my explanation of the solving of the inequalities here. So when you solve absolute value of -x over 5 less than 1, I should have actually left the -5, the -x over 5 here, and then broken it up to be -1 less than -x over 5 less than 1 like this. Okay, so not drop the negative at all. That being said, though, when you multiply, in this case to eliminate, we multiply both sides by -5. So let me just do that here real quick. Multiply both sides by -5, we would have gotten, I'll just do it right down here. We would have gotten positive 5, x, and then -5 over here. But remember, when you multiply both sides by a negative number, when you multiply it by a negative number and an inequality, it flips the inequality signs around like that, and so you still end up with the same interval of convergence there.
So does it still work?
So it still works, right? And so back to this then, Kara, I should have left this a -8, right? Because when you solve an absolute value inequality like this, it just solves like so.
Isn't it the same thing?
It will end up being the same thing, but it's now the same thing for the right. But it's not for the right reason that it ends up being the
But with
correct
the
solution.
absolute value, can't you just take out the negative?
I think that would work, yes, but but this way at least now I don't have to worry about explaining why the x minus 3 doesn't, change as well. Okay, so anyway, now you multiply both sides by negative 8 there. Okay, and you get this, again, flipping the inequality signs because we multiply both sides by negative 8, and then you add the 3, and you get what you should have gotten. Like that, and so center is still 3, radius is still 8. Okay, so does that make more sense now, Kara?
Yeah, that makes sense.
Okay, sorry about that. Thank you for asking. Yes, Kyle?
Couldn't you just drop the negative because the whole, sorry, couldn't you just drop the negative because the entire term is like negative? Like from the top part of the sum, it's minus negative, then the whole term.
Right.
Not just the 8.
Right, but so I guess that so you want to so what would be your argument? So it wouldn't be work. So I don't know. When you say drop the negative, you mean drop the negative just from the 8, or you drop it from like and make it x plus 3 over positive 8? Just from the 8, yeah. So the term, right. So I think that would be okay, I guess. So you're saying why not? Because it's sorry. Say what you were saying again there.
Because it's x plus, and then both the terms are positive, and the x minus 3 is in parentheses, so you minus the negative would be the whole term, the x minus 3.
I see what you're saying. Yes, I see what you're saying. Yes. Okay, so you're saying here from this over 8, you're saying 1 minus, you can make it negative x minus 3 over 8 like that, or you could say 1 minus x minus 3 over negative 8 like that. So either this one or this one, and then when you make it positive absolute value, it would still work out kind of thing. Yeah, I see what you're saying. Yes. I think that's right. Yeah. Okay. So my apologies there on that. Long story short, right, when we're solving this absolute value inequality here, and we want to be less than 1, okay, we take what's inside there, put it between the negative 1 and 1, and then we solve kind of thing. Okay? So that's that. Any other further questions on that? Okay. My apologies there. I shouldn't have deviated what I had written down here, but I did, and that's what caused the problem. All right. So moving on here, evaluate the integral of 6x over 1 minus x cubed dx using power series centered at 0. Right? So this kind of integral we may not be able to do besides using power series. So for example here, a u substitution, right, it wouldn't work. We couldn't use a u substitution because if we let u be 1 minus x cubed, our du would be 3x squared. We don't have x squared, we just have x, right? We could potentially try using partial fractions here. I don't know if that would work or not. Okay. I'm not quite convinced it wouldn't work, but I think it would be more complicated than we want to here. So we're going to do this using power series instead. Okay? So, if we look at this here, okay, we have f of x, and that our function here is 6x over 1 minus x cubed. Okay? So, the formatting of this function is, it is a what? It looks like it's geometric, right? Geometric series. We have our first term. We have over 1 minus what might be a common ratio here. Okay? And according to the way this is formatted, where is it centered? At 0. And isn't that exactly what we want? So we don't have to worry about any sort of manipulation there. It's already centered at 0. Okay? So there's no manipulation necessary to center it elsewhere. And so we'll just go ahead and say, okay, well then, the function, because it's geometric, will be equal to the sum, this geometric sum then, right? A term times, and then our r here is what? X to the third, and then raise that to the n, of course, for our series, or x to the 3n if you like. Okay, so in other words, the first few terms are going to look something like this, right? We'll have 6x, and then we'll have 6x to the 4th, and then we'll have 6x to the 7th, and 6x to the 10th, and then so on and so forth. Okay, so now that we have f represented as a power series, but we don't want that, right? We want to know what the integral is, and so we're going to integrate x, or f of x with respect to x, which means we're going to integrate this sum from 0 to infinity of 6x x to the 3n. I'll go ahead and just put that together there. Okay, dx. Which is equal to, well, let's go ahead and just do that to the series here, right? I mean, you could do it to the individual terms and then come up with a pattern from there, but we can integrate this just based off of what we've got written right here. Now, there's a little bit more simplification I can do here, right, of this series before I go ahead and integrate it. What else can we combine together here before we go about integrating? The x's, right? They're the common base. So x times x to the 3n becomes what? Well, careful. What's the exponent for this x right here? It's to the 1, right? And when you multiply, what do you do with your exponents? Add them. So it becomes 3n plus 1, right? So that's the series. And now we can just integrate this thing, right? We just use the power rule. So when we integrate x to the 3n plus 1, it's going to become x to the what? Yeah, 3n plus 2, right? We just add 1 to our exponent there. So it becomes 6x to the 3x plus 2 over, divide by the new power, right? 3x plus 2, or 3n. Sorry, I shouldn't put an x there. 3n, and 3n plus 2 in the denominator there. Okay. Remember, we're integrating with respect to x. We're treating n like it is a constant right there. Okay, treat it like it's a constant there. And, of course, then a plus c at the end. Is this series geometric? How can you tell? Too many numbers. Well, let's take a look. So the first term will be, well, we plug in a 0. It'll be 6x squared over 2. Then the next term, which will be n equals 1, 3 times 1 is going to be 3 plus 2 is 5, so it'll be 6x to the 5th over, and then 1 times 3 is, so 5 again there. And then it'll be 6x, let's do it for 3. 3 times 3 is 9 plus, or no, sorry, 2. 2 times 3 is 6 plus 2 is 8, so 6x to the 8 over 8 plus dot, 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 you get the idea here, plus c. Looking at this, right, how can we see this thing is not going to be geometric? What makes a geometric series geometric? Multiply the same thing every time, right? Now, certainly in the numerator, we are multiplying by the same thing every time. We're always multiplying by what? X to the third, right? We're multiplying by another x to the third every time. But in the denominator, to go from 2 to 5, you'd have to multiply by 5 halves. But then 5 times 5 halves won't give us 8, right? And so it's that denominator that kind of throws off the geometric or not geometric nature there. Okay, so this is not geometric. We started with something that was geometric, but it integrated something that was not geometric. Okay, so just be aware of that. If you start geometric, it might not end up being geometric when you take the derivative or the integrate or something like that.
Bless your soul.
Okay, bless you. Yes, bless you.
So did I.
All right, let's take a look here at the next one. Any questions so far? We're still good? All right. So number 4 here. If h prime of x equals 1 minus 3x plus 9x squared minus 27x to the third plus dot, 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 right? We're going to write the function that's represented by that h prime. And then we're going to write the Maclaurin series for h. Okay. So when I come up with a function, write the function represented by h prime of x, and then write the Maclaurin series for h of x. Or just plain old h of x. Okay, so, well here, we are not told what this series is, right? It's alternating. It's alternating, right? So, could it be sine of x? What's it missing to not be sine of x? Okay, there's no factorials, and also it's got both even and odd powers too, right? So it can't be sine. Could it be cosine then? Nope, can't be cosine. Could it be e to the x? E has all the factors and or all the factorials and all the powers, but again, what are we missing in this case for the e to the x? Yeah, there's no factorials, and of course, e to the x, does it alternate? No, it does not alternate, right? E to the x is either all positive or all negative, right? Depending on what form you're, or what formatting, I guess, stuff like that, transformations, I should say. And so that leaves then geometric. Okay, and in fact, that's what it is here. All right. Because of course, you know, you won't be, if you're on the wild doing these problems, you might not be told that the series is geometric. You have to recognize it as being geometric here. So we have to eliminate those other three. And so it's just geometric is what's left over, right? So we must be multiplying by the same thing every time. Okay, so h prime of x, if it's geometric, and the question is, right, what is r? We know what the first term is, right? It's 1. We're given that. What is r in this case? What are we multiplying by every time? Yeah, a 3, but it's negative 3x. Exactly right. Yeah, r is negative 3x. Okay, exactly right. So then h prime of x is pretty easy to write, right? It's just going to be the sum from 0 to infinity of our first term, which is 1, times that negative 3x to the n. Okay. How we answered the question that was being asked, though? Is that a function? No. It's a sum, right? It's the series notation. So we're going to rewrite this then. Now that we have it, but we have it, right? So what is this as a function? Well, remember we know what this sum is. It's 1 over 1 minus our r, which is negative 3x.
Can we write 1 plus 3?
Of course you can, yeah. So 1 over 1 plus 3x. Yep. Very good. And that's probably preferable, of course, too. So yes. Good. Okay. And then it asks us to write the Maclaurin series for h of x. Okay. Asks us to write the Maclaurin series for h of x. So, well, we know that h of x is the integral of h prime of x here. Okay, with respect to x. So let's take a little bit of a closer look here at h prime. I'm going to rewrite h prime ever so slightly here, right? H prime we know was, well, the 1's not important, so I'm just going to kind of not write that here. We have that negative 3x to the n, which is really the same thing as negative 3 to the n, x to the n, right? It's helpful to kind of pull apart our variable piece to x, and then of course our coefficient there, the negative 3 to the n part. Okay. So then, why don't you guys go ahead? I've got it in the form there for you. Integrate that. Okay. So let's go ahead. Take 30 seconds or so and integrate this thing. Okay, and write what that would equal. So take your series there and integrate it, okay, with respect to x. Okay. So, something like that. Okay. Add 1 to the exponent of the x, right? We're integrating with respect to x. At negative 3 to n, that's going to be a coefficient, constant kind of thing. That doesn't, we don't integrate that in. We're integrating with respect to x. Only the x, kind of there. We add 1 to the exponent, divide by the new power, and of course, don't forget the plus c because it is a, indefinite integral there. All right. Now, of course, right, that's the power series for the integral of h prime, right? That is the power series for h of x. But what if we wanted to come up with the actual function, right, for h of x? Well, we know what h prime is, right? H prime is exactly 1 over 1 plus 3x. So if we wanted to find h of x, this power series is also equal to just the integral of 1 over 1 plus 3x. Okay. All right, so this power series is the integral of the function represented by h prime as well, right? So we can just integrate 1 over 1 plus 3x if we wanted to get the actual function. Now, granted, the question was, write the Maclaurin series. We're doing that, right? We did do that, okay? And we know it's Maclaurin, it's centered at 0 there. But we could also integrate this function. How would we integrate this function? What strategy or technique would we need to use to integrate this? A u sub. U would equal what? 1 plus 3x. So then our du would be 3x dx. And again, Mr. Goff does it slightly different than me. I'm going to make it 1/3 du equals... oh, not 3x. Sorry, I did this last time. I did this too when I was going over the notes. It should be just the 3 dx. Sorry. So we have 3 dx equals du, and so then do 1/3 du here. Well, that's probably a good thing because I'm making mistakes. So there it is. Okay. So 1/3 du equals dx, like that. And so this ends up being then 1/3 natural log of the absolute value of u plus c, which is 1/3 then natural log of the absolute value of 1 plus 3x plus c. Okay. So in other words, these two things are equivalent. Okay, that's the power series for the 1/3 natural log of the absolute value of 1 plus 3x plus c. There's the series, centered at 0, right? Centered at 0. But those are equivalent. Okay. Okay, letter B here says find the ratio of convergence of h of x. Radius of convergence of h of x. But what test are we going to use to find that?
The ratio.
Right, the ratio test. Because we established, right, that this thing is no longer, well, now you can see, right, our answer here, h of x is no longer geometric, right? It's no longer geometric, so we have to use the ratio test to determine the radius of convergence. In order to determine the radius of convergence, do we need to check endpoints? All we're interested in is the radius, so the answer is no, we don't have to check the endpoints, okay?
Thank God.
We can just identify the radius there, okay? So, why don't you guys go ahead and do that. Find the radius of convergence there. Just the radius, again, not the interval, just the radius is all we need there. Oh, so I'll write this. So h prime is geometric. H is not. So, ratio test. Okay. Say, sorry? Yes, use the power series there, yeah. And the ratio test with the power series there. Yes.
Would the n plus 1 and the n on the top and the n plus 2 on the bottom, would the n's like cancel out?
So that's going to go to 1, right? Because you're taking the limit as n versus infinity, so
Right.
it's
So
going to
it would
go to 1.
be like with these two, but like
So yeah, so, and I'll be careful, it should be, let's see. Since this was x to the n plus 2, and this is x to the n plus 1, when you subtract your powers here, the n's will cancel, and it's 2 minus 1, which will just be a 1 there. Yeah, and then yes, this will go to 1.
oh my gosh.
So I know, yeah, I did that, I ruined your notes, so. So then you're left with just negative 3x, which you should have there, negative 3x.
Why don't you just have 3x? Oh,
Right, absolutely negative 3x there, so.
what, can you just have 3x?
I mean, yeah, that's fine there. It's going to end up being, yeah.
Why does it seem that have so much
lots of junk. Interrelated junk, but still junk. All right.
So these,
That's not 3, that's a third.
Careful, how do you solve the x there? Yeah.
these go to 0 or go to 1.
Correct, that would go to 1, so yes, you're left with negative 3.
Wrong.
I did the same thing yesterday morning, so I feel your pain. I know that feels wrong.
Didn't do it on Saturday.
Alright, I'm gonna punch your shoulder.
So n plus 2 and n plus 1, right? They're same base, so you subtract the x plus 2.
Two.
N plus 2 minus
They weren't
the
even
Dare I
cast
say
on bet.
3?
n cancel.
Are we all, I think we did number 3 on this one?
This should be negative 3 to the n plus 2
Okay, I'll-
power.
Seems like
This
you have
should be
a rough
negative 3 to
morning.
the n plus 1.
Just looks like
Happy
So remember this
Yeah.
is
I wish I could be
3x
happy about
to the
tomorrow.
n. Anything is saying 3 to the n
No,
times x.
oh, 4-hour car ride by myself.
So this is also the x to the n power. So to find that next term, you need to make it negative 3
It's
to
a
the
lot,
n
yeah.
plus 2. Like this would be
It's a sad day. It's a really sad day.
negative 3 to
Are you
the
going for an actual visit or just by yourself?
No, I'm going on junior day. So I'll watch the practice, so if I can put on the jersey.
We not contacted, we were visiting it.
I'm excited for that.
No, no,
So
that was
for
the time
the-
I give it.
Then I'm not gonna be here on Monday next week, so I'll be driving back from Harvard.
Yes.
Yeah, it all sucks.
Are you looking at Ivy?
And I'm picked off.
I know, I guess I can consider myself
No,
smart.
but also
Your life must be so hard. I know.
Driving by myself, yes.
radius.
I feel like you're a really bad driver, I don't know
I
why.
did the same thing that last. I did that yesterday.
You know who is a really bad driver?
Don't say me.
That's fine. I see your story. Think about it. All right.
A person who hits a
Okay, you should have gotten r equals 1/3. Okay. Your radius there is 1/3. All right, so again, you do the next term. So there's my next term, right? Negative 3 to the n plus 1, x to the n plus 2 over n plus 2. And then the previous term, n plus 1 over negative 3 to the n, x to the n plus 1. Okay. Simplify. You get negative 3x and then the n plus 1 over n plus 2. I went ahead and showed like the longhand form here, right? Sometimes we just do the shortcut and say this goes to 1, and I would jump, sometimes you just jump from here to here. But if it is a free response question, you do want to see that you do need to apply L'Hopital's there. All right, it's only once, and then you get the, what you need, the negative 3x times 1 over 1, less than 1. Okay? If it is a free response question, you need to make sure that you're writing apply L'Hopital's, that you're showing that it's indeterminate, infinity over infinity in this case. That is important. If it's a free response question, you want to establish that stuff. That's part of your work. Okay? So keep that in mind. All right. Questions on any of that? All right. I do want us to get here to A and B on example 5. So, we can try and get through this here. I think we should be able to. Okay. Sorry that time got away from us here, but I think we would finish this up here. So let's just do that. All right. Maclaurin series for the function f is given by that on its interval of convergence. Okay. A, find the interval of convergence from the Maclaurin series of f. Justify your answer. Okay. So, is this going to be geometric? No, sadly not. Okay, we're not going to be multiplying by the same thing every time. Yes, that 2x is to the n power there, but n minus 1 is not also to the n power. So we're not going to be multiplying by the same term each time. And of course, that's going to be changing anyway. The n minus 1 will be. So it's not geometric. So that means we have to use what to find our interval of convergence? The ratio test, right? So limit n approaches infinity here of, and again we'll do the next term. So it'll be, and I'm going to drop the alternating piece, because it's in the absolute values there. So it'll be 2x to the n plus 1 all over n times, and then n minus 1 over 2x to the n there. Okay. All right. So,
Wouldn't it be over n plus 1?
well, it was n minus 1, so when you add 1, it just becomes n there. So we can kind of see here, right, what's going to happen to this n and n minus 1. They will go to 1, and then we'll have 2x to the n plus 1 over 2x to the n. That just becomes 2x, right? So we're going to have 2x times n minus 1 over n. And again, we want to know when that's less than 1. So really, it's just going to be then the absolute value of 2x is less than 1, so negative 1 less than 2x less than 1, so negative 1/2 less than x less than 1/2. Okay? All right, and that's our interval of convergence, right?
No.
No. Oh, man, this is ratio test. So what do we have to do? Test those endpoints. That's right. So if x is negative 1/2, we plug negative 1/2 in, we'll have the sum from 0 to, not 0, sorry, we're starting from 2 there. 2 to infinity, negative 1 to the n, negative 1 to the n over n minus 1. Okay? Negative 1 to the n times negative 1 to the m becomes a what? So negative 1 to the 2n, or positive 1, right, to the n power. So this becomes just 1 in the numerator there. That's nice. They'll always be the same. Either they're both going to always be negative or they'll both be positive. So it's always just going to be 1 in the numerator over n minus 1. Well, what do you know about 1 over n minus 1? It will diverge, okay? Because if you compare it to 1 over n minus 1 over n, right? By comparison to 1 over n, okay? So diverge. So we're not going to include x equals negative 1/2. Let's try positive 1/2 here. Okay, that's going to be negative 1 to the n times 1 to the n over n minus 1. Okay, or in other words, just negative 1 to the n over n minus 1. So this series is what? It's converging by what test? Yeah, it converges by alternating series test. And again, I just don't have time to go through the 2 things to check. But again, the 2 things you check for alternating series. 1, take out the alternating part, so 1 over n minus 1. Does the limit as n approaches infinity of 1 over n minus 1 go to 0? Yes, right. Is the next term less than the previous term? So the next term here will be 1 over n, and that is smaller than 1 over n minus 1, right? So that would be true too. So it does converge by alternating series. So the actual interval of convergence is negative 1/2 less than x less than or equal to 1/2. So we include the positive 1/2, but we don't include the negative 1/2. Okay, and then we're almost done here. Last piece, letter B. I think we're going to make it. Maybe I'm being optimistic. Okay, so show that y equals f of x is a solution to the differential equation xy prime minus y equals 4x squared over 1 plus 2x for the absolute value of x less than r there, where r is the radius of convergence from part A. Okay, so for the same radius of convergence, basically. All right, so f of x, I'm going to write out the first couple terms here, just kind of get us started. So if we start at 2, negative 1 squared will be positive 1. 2x to the 2 becomes 4x squared. And then 2 minus 1 is just 1. So it's just 4x squared for my first term. And then the next term is going to be, well, if I put in a 3 here, negative 1 to the third is now minus. 2x to the third is going to be 8x to the third. And then 3 minus 1 will be now 2. So 8x cubed over 2. And the next term will be 16x to the fourth over 3 minus dot, dot, dot. I'm not going to keep doing that. We'll just do those terms right there. Okay, so that's f of x. But again, we want to show that this is a solution to the differential equation xy prime minus y. So in order to kind of do this differential equation, I'm going to take y prime, multiply by x, and then subtract a y. So here's f of x, which is the same thing as y, right? We're told that y is f of x here. So if I want to find y prime, what do we need to do to these terms? Take the derivative, right? So y prime then is going to be 8x minus, and if you'll permit me here, I'm going to simplify. 8 over 2 is 4, and then bring the 3 out front. So it'll be then 12x squared, right? And then 16 over 3 doesn't simplify, but let's see here. So it'll be like 64 thirds x to the third. Okay, minus dot, dot, dot. Now we'll multiply an x in, though, because it's not y prime, it's xy prime we're looking for right there. So I'll make this not y prime now, I'll make it xy prime, which gives us 8x squared minus 12x to the third plus 64 over 3x to the fourth minus dot, dot, dot. And we'll then subtract y. So that's going to be a negative. And then again, what's y? It was that 4x squared minus 8x cubed all over 2 plus plus 16x to the fourth over 3 minus dot dot dot. So xy prime minus y, and we'll just combine like terms. So we're going to do 8x squared minus a 4x squared, we're left with 4x squared. Negative 12x cubed minus a negative becomes plus positive. So we're going to do minus negative 12, but then add a positive 4, so it becomes minus 8x to the third. And then we have a 64 thirds minus a positive 16 thirds. 64 take away 16 is going to be 48 thirds, but 48 thirds is really 16. So we're ending with 16 x to the fourth there. Minus dot dot dot. Okay. What do you see is happening here? What are we doing each time to get to the next term? Multiply by a negative 2x. And if we're multiplying by the same thing every time, that means it is what? Geometric. The sum of the geometric series is the first term over 1 minus the common ratio r, or if we combine it together, 1 plus 2x. OMG, that is exactly what we're trying to solve for. Okay,
Wait, what?
that's what we're trying to show. That's equal to 4x squared over 1 plus 2x there. Okay, we made it, so it's geometric. First term, 4x squared, r equals negative 2x. Okay? Sorry guys, squeezing that in there at the last minute, but there it is. All right. Anybody for a set? So Ariana.
Oh, Michael.
Michael. Oh, Michael. Aubrey. Okay.
Jordan, you didn't call
Miss
me in.
Ryder. Gotcha. I'm sorry. Gotcha, Madison. Thanks. Oh, Madison.
What?
Anybody else for set? All right. Y'all have a good day.
Has it gotten to its hardest point yet?
I might not use it, but.
This is a little bit. This is pretty tricky, I would say, because of all the manipulation. The one other thing we're going to be looking at later is the error, and that can cause. That's a little tricky, I think, too. Apparently. So, but this is pretty rough, I would say. Yeah, according to Mr. Goff and stuff. So.